Hi everyone, thanks for watching. Today I'm going to show you my latest invention. I call it the Terra controller. It's basically a clone of my Hydro controller with a few adjustments. If you haven't seen my previous videos, I've built other controllers for hydroponics and many other applications, but this one's iterations of those, so there's improvements here and there. I've managed to make everything more compact. This is the layout of it. This is a 5-inch 800 by 480 display, an R8 8875. Here we have an Arduino Nano. This has an RGB LED, a buzzer, and two 0-point cross detection modules connected to it. These control the fans, 2 fans, one each. This is for air indications and such. I've got another controller. So this is effectively a slave connected via I2C to the Arduino Mega 2560. I needed 2 MCUs because this one needs to run extremely fast because I'm cutting up the AC waveform, and at 60 Hz I need to be running within 100 microseconds, and this code actually loops within 18 microseconds. On average it actually loops within 12, sorry, not 18, so it runs more than fast enough. It's very efficient code using port manipulation and registry writing. Other than that part itself, we have a DS3231 RTC, 4 MOSFETs, PN55FN, I think they're something close to that, 55FN. We have some kickback diodes and some resistors. It's just basically a standard MOSFET circuit, and each MOSFET is running a doser. You could have up to 10, but for me I only needed 4. What else do we have? Obviously I've showed you the Mega, and here we have 8 relays. Sorry about these cables, it looks bigger in the camera but it's actually quite small. We have an 8 relay channel board here, if my camera will focus. And sorry about my writing, but there's a relay for the light, a CO2 regulator, plant 1, plant 2, plant 3 and plant 4 relays, and they control some solenoids. I have the solenoid over here, but I'll describe it in a second. We also have a backup relay for an additional solenoid, just in case one of them fails, and an air heater. I'm grabbing the component. Solid brass, it's very heavy. This is my matrix, and it's got a quick fit connection on the end, so it can go straight onto my 15mm speed pipe. And here we have a solenoid valve to close down, and this is the backup solenoid. When that opens, the water would flow, but it would only go so far because there's actually a solenoid for each plant, and this allows me to have a moisture sensor in each plant pot and only water the plants that are required. It works dynamically, so the relays, this relay would always open up if any of the other relays are active. So let's say we're watering all 4 plants, all these solenoids would open up, and let's say we've set it to water 1 litre per plant. The flow sensor here would then wait till it's incremented to 4 litres, and then obviously shut off the valves. So it accounts for pressure change and such things, and allows me to just water the plants I need. It's nice and high quality, and that's essentially how the watering the nutrients is done intravenously with a mix tank, a flask, about a 200ml flask. I don't have it on here, but there's a hose attachment with a T-valve to the mixing cup, and I've done it at the end of the matrix rather than in the middle, just because there's a pressure drop. This is rated for 15 litres a minute, so I've actually got a stopcock on the copper pipe, and I've set it mostly close to the point where it's about 10 litres a minute, and therefore with such a low flow rate and going out to X amount of outlets, the pressure is actually low enough that even if it wasn't a parastatic pump, it wouldn't run up the dosing line. But where we are using peristatic pumps, they are actually one-way, essentially one-way valved on them. The water cannot return back up it. So therefore, I did do some initial tests before I paid all this money and built this big one, and it does work. So in the sense that when the valve opens up, the doses will run at the same time. You have just a Y piece or a T piece valve on there, and you, let's say doser 1 might go to all these pumps, or you might have just doser 1 for plant 1. Again, you could have up to 10 doses, but for me, I would just have the doses going to all the outlets, and yeah, it would just dose X amount every time the plants need watering. I'll show you the menu. It has obviously multiple configurations. Before I do that, so I'm just going to put this down, I don't want to smash my glass table. There we go. We have some sensors obviously. So as I said, we measure the plant moisture. Here I am using capacitive soil moisture sensors. I'm using capacitive soil moisture sensors because I had previously used, sorry, I'm just going to grab my bits and bobs. I previously used the standard soil moisture sensors, and they're rather short-lived. If I can get my camera to focus. Now, you may not be able to see it in the camera. I'm trying to focus on the object. Come on. This is a good phone, but a terrible camera. You're going to really be this bad. There we go. You can see all the corrosion. It's completely corroded, galvanic corrosion, and that's because of the way these simply work. And I was even being clever enough to swap poles from positive to negative and isolating the sensor. Nonetheless, they still corrode. To bring it up in a minute, I have got a BME barometric pressure sensor, but there is a flaw to these, and I'll explain that in a minute. Let's put these away. Now, as I said, I'm using capacitive soil moisture sensors, 1 for each plant, 1, 2, 3, 4, and I also have a DHT22. Now, I'm using a DHT22 instead of the barometric pressure sensor, simply because the barometric pressure sensor works via I2C, and the cable length must be quite short, or you must have an incredibly well insulated and highly rated cable to carry the signal if you're going to try and exceed 2 meters, whereas with the one wire protocol you can achieve a greater distance. So I'm using the DHT22 for that reason. I also have an LDR down here somewhere. There. And that is simply so I can measure if the light has failed. By that I mean I've had timers fail on me, I've had ballast short out and other such things. So it's nice to have a error log that tell me if something has failed. After explaining all the parts, I can now start it up. If you've watched my previous videos, some of my old schematics were using voltage regulators like an LM117, and I was using a 12 volt power source. Now that has its flaw because the regulators get hot, it's just additional circuitry, and when I buy them I normally needed for the whole circuit between 3 to 4 of them. I mean, you could have probably done it with just 2 if you bought higher rated ones, but nonetheless they're not cheap, and for just £10 I bought a 10 amp 5 volt switching power supply. It's not a knockoff from China, it's from RS Pro, a well trusted electronical supplier. If I get it, it's just down here. In fact, I've got one in a box because I'm building something for a YouTuber at the moment. There it is. RS Pro 5 volt 10 amp. It's very small. I'd say it's about 4 inches by 4 inches, about an inch thick. And then I'm just running a standard barrel connector to a 2.1 millimeter pin plug, and I've got a nice little switch, so let's turn it all on. Just booting up. I've got that splash screen just to allow my I2C devices to power up, because the I2C protocol doesn't have a timeout request, so if the device isn't present at some point, it would just literally, the whole program will freeze, and there's nothing you can do about it. It's probably another reason why I wouldn't be using the barometric pressure sensor, just because if the user unplugged it or something, the whole program would stop responding. As you can see, we've got the home page. It's got an automatic slideshow. Well, I say automatic, it's a slideshow that increments every 10 seconds. And it's got the sensor value, your target, so target min max, and if there's an offset for the given sensor, it would also have the offset next to the target. You can obviously slide along. There we go. Yeah, temperature's got an offset of 2. Let's go on to the actual menu itself. Again, this is a basic clone of my hydro controller, but I'll explain it for those who haven't seen it before. As you can see, it's got an outer menu. I designed it all myself. I don't copy the code off of anyone. I write everything and design all the icons, absolutely everything myself, minus the display, driver library, and the library for the DHD22 and the DS 3120B, the Dallas temperature sensor essentially. But everything else, read all the code myself, including the graphs, keyboards, all the other such functions. There's an alarm going off over there. That's nothing to do with this. Let's have a look what I'm typing. Right, so pressing the first one, we've got a graph page. Again, a slideshow. We can see the moisture recorded for each plant in their percent value. I'm actually going to change that to a raw reading though, so this is an old version. Got obviously then our CO2 sensor, fan 1 speed, fan 2 speed, air temperature, and our humidity. And then back to begin obviously. We've got a maximum page. Yeah, exactly same kind of stuff. They're all 0 at the moment because I've just got no sensors, so I've got the sensor function disabled. I'm just running some other stuff at the moment, some tests. So the sensors currently aren't being read. You can save profiles, so all the values that you've adjusted here, including most of the settings, you can save it to a given profile, such as one for vegetation, one for flowering, and whatever else. If I click on this, you can actually rename them. Again, it's all myself. Just write something, so I'm not going to look for my phone, I'm just going to look at the keyboard. Let's go to an uppercase character. Where's my finger? That's my name. Yep. Currently it's highlighted that we're in profile 1. Save the settings till last, so we'll jump straight over to the plants page. Got a plant 1 moisture, plant 2 moisture, plant 3 and plant 4. Now I'll explain this. This is the target moisture, but this is automatically set. So if you had a new device, or you've reset the device, or you go into the settings and calibrate the moisture sensors, what that effectively does is what are you doing over there? Effectively it calibrates the soil moisture sensors by you place the probes. So I'm laughing about what my dog was doing. You place the probes in the plants pots, one moisture sensor in each plant obviously. You then press calibrate and it would set the moisture value automatically. So I didn't explain that properly, sorry. Let me explain it again. You water your plants to the perfect moisture, so you're happy with the exact amount of water that's in the soil, and then you press calibrate, and it will take a reading, and then it will be saved, and then X time when it waters the plants, it would say, is it below your target moisture? Yes. Okay, it needs to be watered. I hope I explained that correctly. So this is the target moisture when they're perfectly watered. When it drops below this value at its check time, it would then be watered. You can set a tolerance, plus, minus, whatever amount. I'll go into the water page. So this is what I'm explaining. You can have 2 timers if you wanted, but I've just set 1 for now. You can go into settings and set it for 2 timers. So this is the amount of water per plant in litres. So this is timer 2. I did enable it. And then water timer 2, water per plant. So again, if you wanted to say water once in the morning and then once in the evening, you can do so. You can disable timer 2 completely if you wanted to, so it's just once a day. I probably will, as I said, this isn't finished. I just started writing this 2 weeks ago. I'll probably put a calendar in there as well, so you can actually say what days you wanted to. So maybe you don't want to water them every day. Saying that, I'd already thought of that, and there's a water per intervals. I'll get round to that. I can't even remember what I wrote. We've got, as I said, you can have up to 10 doses. Just for this bit of code, I've set it to 6 in here, just so I can show you scrolling along. There'll be 6 of them. And of course you can prime them, so... where are we? That'll be dose 6, that won't help. Obviously I've only got up to 4 doses, we'll go back. Sorry about this unprofessional video, it's probably my worst one. That one is overview. And of course you set the millilitres per doser, so when it waters it would do X amount of millilitres. You've got your CO2 page, so your target CO2 and your tolerance, much like the other pages. This isn't automatically set, you would set this manually. You have to set your room dimensions and the flow rate of your CO2 regulator, and then I should change that from interval, it should be time. That's not even centered properly. That would be the time that the CO2 would go off, and whether you'd want to disable the fans X amount of time whilst it's doing the CO2. Just wheel my chair forward a bit. What else we got going on? We've got a light page. So light on, light off. If it was on, auto or off. Currently that relay's on, that is there, the light, that little red light there. I'll just turn it off. There we go. I'll turn it back on. Cool. Obviously, nice and responsive. Going to the next page. Oh, almost accidentally slip my finger along a bit. Fan 1. This is the fan page. So, fan 1, min and max speed. Fan 2, min and max speed. And fan settings, control temperature, control humidity if you wanted to. If you want them to be running at fixed speeds, so not automatically controlled by whether the temperature is high or low or the humidity is high or low compared to your set points. So that's the next 2 tabs. You've got your target air temperature, min, max and your tolerance. Goes up in 0.1s. Your tolerance could be 0 if you wanted to. Much the same for the humidity. Going on to the Wi-Fi page. I don't have the Wi-Fi. By that I mean an ESP8266. I don't have one present. By present I mean I don't want to have one plugged in. I haven't written the code, but I've already got the code for the hydro control. The hydro controller. So essentially it's just change some of the values and then just adjust the web page. But that's not something I give out to others because it's my own private server and I haven't set up some kind of security means to allow others to log on and use the database and such. But nonetheless, it's got Wi-Fi page and obviously Wi-Fi capability. And then you've got your warnings page. Yes, so this is the raw value, so I don't know why I've got the percent in there. So this is the current sensor reading. So obviously I need to adjust that so that it's got no percent at the end. Other than that, it's correct. CO2, yeah, there's nothing there. Yeah, temperature, yeah, that's bang on. It's my margins. I had an offset of 2, so it was at whatever it was. And humidity is fine too. Obviously you can set your air margin, so that's plus minus the current reading. So if the current reading is 45% humidity, I would say with air margin of 5, if you go below 40, then give me some kind of minor or major warning, depending on how much out of range it is. So that's all those pages. Then you've got your settings pages. So you've got your background colours if you really wanted to. Yeah, want it pink if you wanted to. But I'll go back to blue. I like blue. As usual, I'm trying to look through my phone's display to where my finger goes. There's no sense of depth to it, it's quite weird. Display timeout, maybe you want that off. I'll turn it off the rest of this display, this rest of this video. Graph interval, how often the graph updates its values. Set the date time if you wanted to. We don't need to obviously set it, but I'll press cancel. Oh, where's my finger? I'm getting pins and needles in my hand then. Temperature in Fahrenheit, obviously couldn't fit Fahrenheit in there, but temperature in it, Fahrenheit. Height in inches, so that'd be for things like the room dimensions. On to the next page. Number of plants, number of doses, as I said, you can adjust those. Auto watering mode, so that would be, as I said, if it automatically, it would check if it drops below your target values. You can have timer 2, so in that sense it would just go at a set time. If you have auto watering disabled, you can disable plant control, CO2 control. Oh, where are we at? Going down. Disable fan 1 if you wanted to, maybe you don't have one, or fan 2. Oh, that's the end of menu because Tara's pointing up now. System logs, so in my code, again I'm just playing with some functions here, so I've told it to make 6 logs. Yeah, they're all going at the same time because I just told it to generate them at exactly the time. So as you can see, light on, it's like, these are just normal logs, light on, light off, adjusted CO2, water plants, error, water leak. So essentially, if all the solenoids are closed and the flow sensor detects water still flowing, then obviously one of the solenoids is leaking, so you can get leak detection. Obviously, if the solenoids open up and the flow meter doesn't detect any water, then you get an error saying no water, and then you get like error, light off, because we're using the LDR to detect if the light's on. Oh, I forgot to put an exit button on this page. Oh, that's quite funny. So I'll just go back. Again, this isn't a finished version, I've just been writing this through. Now you've came down. I'll play with you in a second, I'm almost done. So where are we at? Where were we at? Did we go this far? Yeah, it was at system logs. Disable LED if you wanted to, that thing's annoying me. Turn that off, cool. Disable the speaker, why not? Disable CO2 sensor, yeah I don't have one present. Disable air sensor, that really shouldn't even be there. Because you should always have them present. Calibrate moisture sensors, this is what I've been on about. I should have just waited till I press this. So, as it says, please place soil moisture sensor 1 in soil that has a perfect soil moisture content and compact soil, and press continue to calibrate. Cool. Same kind of thing for this one. Exactly the same again, it's just the numbers changing there if you haven't noticed. It's saying sensor 1, then it says sensor 2, then sensor 3. Obviously I have 4 sensors, so it's going to say do 4 sensors. And then if we went back to the plant page, which we'll show in a second, you'll see the values have been set. Keep going down, what else have we got? Calibrate CO2 sensor. We can show you that if you want. Yep. Please make sure the CO2 sensor has been a constant, or please ensure the CO2 has been a constant 400 parts per million for at least an hour before starting the calibration. Do you want to continue? Nope. Calibrate doses, so this is the speed that they run at. Essentially, they should be calibrated to do 1 milliliter a second, so you just adjust their speed to that point. I don't think I've uploaded the latest code, but it should beep once every second. Yeah, so it's not in at the moment, but it should beep once every second to indicate to you. And if you look in the serial monitor, it would also tell you, primed 1 milliliter, 2 milliliter, 3 milliliter each time it beeps. And you should have a little measuring cup when you're calibrating, and you should press it for, let's say, 3 milliliters and look in the cup and say, well, that's 3.5 milliliters. I'll slow the doses down a bit or speed them up. I've just got to run them at 100% speed at the moment. Essentially, it's just speed times 2.55. I'll exit here. If you're a more advanced user, I could probably put a setting in there to say PMW speed, so you get a bit more control. Maybe I should just change it to PMW anyway. Clear Wi-Fi details, so like some old projects, you can press a button and it would send a command to the ESP8266, and the Wi-Fi manager library has functions to delete all the EEPROM settings for the Wi-Fi and clear all the SSIDs and all the history and stuff like that. Essentially just completely wipe all the Wi-Fi details. Obviously you can clear the graph history, clear max mins, and a factory reset. Go out of that page. Obviously I shouldn't have these in there really. This is more, this is the warning page. I thought I was saying disable sensors. Yep, so you can disable all the warnings for the different sensors if you wanted to. And before I forget, go back to this page, and as you can see, it's set our moistures for you. Pretty close grouping from all the 4 different sensors. As soon as they're just on the floor, one must have picked up a bit of noise or something. It's probably that one on its own. All the other ones were close together. Yeah, so that's my soil moisture controller. As I said, you put the soil moisture sensors in the plant pots. You set what time you want it to water, either in 2 timers or 1 timer. If it's below there, or if you've got it set to automatic watering, it would check if the plants are actually below the target moisture, and if it is, it would then water. Whereas if you have it on manual, it would just water whatever time you set it to do. And here we've got CO2 control, light control, dual AC fan control, and obviously that controls the temperature and humidity. We've got Wi-Fi, got error logging, we have graphs, max mins, save and load profiles, and a whole bunch of settings. And naturally the project itself, which it consists of an 8 relay board, 2 0-point cross detection modules, an Arduino Nano, buzzer, RGB LED, DS3231 RTC, 4 MOSFETs and a standard MOSFET circuitry, an Arduino Mega, I said the 8-channel relay, I'm a bit sure, 4 parastatic pumps, those are 6-volt ones, and an bi-display R88875 800x480 TFT display, running with SPI. Ooh, did I? No, I thought I was going to miss something then, but no, that's it. And obviously the power supply itself. Yeah, and that's my project. I hope you like it. Thanks for watching.